Ever had a bad night's sleep? Imagine trying to catch some Z's while floating in the middle of the ocean. Or even worse, sinking to the bottom of the sea. Ugh, what a nightmare. But it does make you wonder, how do animals sleep underwater? Some oxygen breathers spookily float close to the surface. Some others only sleep half a brain at a time. And some genius invertebrates have nightmares that you can see in their skin. Let's get into the amazing adaptations of the animals who sleep underwater. Hi, I'm Danielle Dufault, and you're watching Animalogic. Today, we're investigating how marine animals sleep. How do they rest in an environment that requires constant movement? But before we get into the specifics, let's take a step back to understand the basics of sleep in the first place. Even though sleep may feel like a simple process, there's a lot more to it than shutting your eyes and drifting off into the darkness. There are several stages of sleep that make up a sleep cycle someone goes through during the night. Your brain behaves differently during each of these stages. Scientists study them by attaching electrodes to the head and watching brain activity while a person sleeps. This is called an electroencephalogram, or EEG. We'll get back to EEGs in a bit. Without getting too far into the weeds of neuroscience, there are two kinds of sleep: REM and non-REM sleep. When you start drifting off, you begin in non-REM sleep, moving into deeper and deeper stages of rest. After your brain has had enough time, it shifts into REM sleep, the phase with rapid eye movement. This is when we dream. Our muscles usually freeze during this part of rest, which prevents us from acting out our dreams. Throughout the night, your brain will cycle through several REM and non-REM stages. Both are essential for the brain and body, and without them, humans and many other animals would die. Many aspects of sleep still remain a mystery to scientists. But one thing is for certain, sleep is critical for life. Knowing this, it becomes even more important to ask, how the heck do marine animals sleep at all? Let's start with one of our closest aquatic relatives, cetaceans like whales and dolphins. These animals have a unique sleeping adaptation. They put half of their brain to sleep, while the other half is still awake. Cetaceans have little to no REM sleep, which is weird because without it, we have issues with memory, mood, learning, and even increased risk for certain diseases, like dementia. Some scientists think that sleeping with one side of the brain at a time may help compensate for this lack of REM. Cetacean sleep may also simply be more efficient, doing the work of REM without having to be in it. I envy that. Dolphins will spend about 8 hours per day in this partially awake, partially asleep state, spending half the time resting each hemisphere in 2-hour-long sleep shifts. Talk about multitasking. But why? Obviously, being an air breather but sleeping underwater isn't the best combination. And so these animals have had to figure out how to not inhale water and how to surface when needed while sleeping. Hanging out right at the surface of the water can make you a prime target for large ocean predators, so they have to stay a little deeper where it's darker and safer. So this kind of sleep gives them the opportunity to get some rest, while also being able to balance these other very important factors. You might be wondering what these animals look like while in this state. Marine mammals don't actually need to be totally still while sleeping. They usually just swim slowly or use basic movements of their flippers and fins to keep themselves warm and their bodies stabilized. They also sleep with one eye open to remain vigilant while also giving half of their brain a break. I should try that sometime. While the thought of a human sleeping with one eye open sounds like something out of a horror movie, for these creatures, it's nothing but a day's work, or rest. In the marine animal kingdom, Even though most research on marine mammals has been focused on dolphins, researchers have also discovered unique patterns of sleep behavior across other cetacean species. For example, sperm whales show an unusual and wildly cool behavior while sleeping, floating vertically in the water. These whales will float in a vertical position, nose up, near the surface of the water, coming up to breathe for air when needed, before going down again to drift in their vertical positions. Now, why do some cetaceans remain moving while others just chill out? Larger whales don't have to worry so much about being dragged by currents, being attacked by predators, or losing warmth, so they can park themselves. Smaller cetaceans worry about all of those factors, so it's safer for them to always be on the move, even while sleeping. While animals like whales and dolphins have evolved their approach to sleeping with half a brain, what about animals that spend some time in the water and some on land? Pinnipeds, like seals, sea lions, and walruses, have evolved a sort of hybrid sleep. For example, seal migrations can include up to 10 months at sea before returning to land. When the seals are on land, they sleep pretty much the same as us, with cycles of REM and non-REM sleep. Like this little guy, who seems like he's about to have the sleep of a lifetime. Lucky. But when they're in the water, they can do unihemispheric sleep, like whales and dolphins, with some distinct features like short bursts of REM sleep. How handy. Or how flippery? You might be wondering how we know all this cool info about seal sleep while they're far out of reach in the open ocean. Over the past few years, scientists developed a harmless neoprene swim cap with electrodes that could go over the seal's head and stay with them while they traveled. When the animals returned to the beach months later, the researchers collected the caps and analyzed the data. Seals have also adapted their own unique way of positioning themselves in the water, using their flippers to keep their heads above the surface for breathing, while the majority of their body remains submerged. In walruses, although most sleep occurs on land or ice, an amazing adaptation has been discovered that allows them to also be able to sleep at sea. Kind of similar to the floating position of sperm whales, walruses can sleep while floating, using special air pouches in their neck area to keep them buoyant. They can also use their tusks to anchor themselves on the ice. And because they're so big, strong, and thick-skinned, predators don't seem to bother them too much. Clearly, marine mammals have some pretty cool sleep features that differ from humans. But what about species that are farther away from us on the evolutionary tree? Enter some of the most iconic creatures of the watery world, bony fish and sharks. Fish have had to worry about predators at all times, so their sleep has had to adapt. Even though they don't breathe air, many fish species need to move constantly to get oxygen through their gills. This makes their sleep a bit complicated. When thinking about bony fish, it's hard to provide a one-size-fits-all description of sleep. These fish species can range from household goldfish in a tank, to clownfish on a coral reef, to piranhas in the Amazon, and everything in between. Fish have adapted several different sleep strategies, but we're only beginning to understand them because until recently, many scientists believed that their brains didn't need sleep. Luckily, more recent research has started to shine a light on sleep in fish, which takes into account broader ways that sleep can exist. One of the most studied species for sleep is the zebrafish. This species shows patterns of activity and rest throughout the day, following light and darkness in their environment. Their sleep is similar to ours in that it seems to have slower wave and REM-like phases. One big difference is the fact that even though their total sleep may be hours during the night, they sleep in short bouts of seconds to minutes. Wondering if scientists have little caps similar to seals to study fish sleep? Nope. But an equally ingenious setup has given us the answers we want. Larval zebrafish are safely immobilized in a jelly-like material and then are given full-body scans. The fish are genetically modified to have fluorescent cells that glow when the neurons are active. Then, eye movement, heart rate, and brain activity are measured. These are the kinds of studies that have shown the human-like sleep patterns in these fish. Unsurprisingly, nature has taken advantage of reduced responsiveness in fish during sleep, leading to both helpful and harmful cross-species relationships. For instance, cleaner shrimp will act as living garbage collectors during the night, eating dead scales and debris from the surface of a fish's skin. But fish are hungry, and it's risky for the shrimp to do its job while the fish is awake. So it hides if the fish is active and comes out when it's sleeping. It's like the tooth fairy, but instead of taking your teeth, it just takes away your dead scales. We don't have any EEG data from cleaner shrimp, but all the evidence points to them also having time for sleep-like rest at some point during the day. Coming back to fish, we've talked about how they rest, but how do they protect themselves when they're napping? Parrotfish have developed the ability to secrete a cocoon of mucus around them, kind of like a slimy sleeping bag. These cocoons take about half an hour to make each night and help to protect from larger predators as well as parasites. No predator wants a mouthful of slime. Think of it as a 30-minute nighttime beauty routine. What does a sleeping fish look like? It really depends on the species and the habitat that they live in. For those living in places with nooks and crannies like a coral reef, these hiding spots can be the perfect place for a napping fish to stay safe. Once asleep, fish will become nearly still, with only slight movements to help them stay floating. Luckily, swim bladders, which are basically internal floaties, keep them from sinking to the bottom. Fish don't have eyelids, so they can't actually close their eyes to sleep. But their eyes do move differently. Their pupils have a slower response, and they can no longer track movements in their environment. In other cases, fish have been found to sleep while floating with their heads pointed downwards. They're like the anti-sperm whale. Some others sleep upwards at the surface, and others simply rest at the bottom of their environment. It's not fully clear which species take the different positions, or if they even do this in the wild at all. That's because these sleeping positions have mostly been seen in the lab. A floating fish would be an easy target for hungry predators, but more work needs to be done to know for certain all the creative positions that fish might take while sleeping. For example, how do sharks do it? Remember what we said about needing water to flow over the fish's gills to keep them alive? Bony fish and some types of cartilaginous species do buccal pumping, which is simply sucking in oxygenated water and exhaling it through their gills. This is useful because it means they can stay still for long periods of time and get all the oxygen they need from the water. But then there are sharks who can't suck in water, so they have to move forwards to oxygenate their gills. How do they sleep? Shark sleep is actually one of the greatest mysteries in fish biology. Some species seem to slow down throughout the day, and others don't seem to have much change in their activity at all. Scientists are still uncertain about what on earth is going on in their soft heads. Is it possible that they don't even sleep at all? This is unlikely, especially for creatures with complex brains like sharks and rays. Or maybe they sleep half a brain at a time, like dolphins? There's no evidence that they can do this, but it seems that some can put smaller parts of their brain into sleep mode. Some species could also use ocean currents to keep water flowing over their gills while they rest. Scientists continue to try and crack this sleep mystery. This mostly involves observations in their natural habitat, looking at changes in things like movement patterns to figure out what sleep looks like in the wild. If we don't know this, you might wonder how much we can know about invertebrate sleep, like octopuses and jellyfish. Surprisingly, a lot. Another spoiler, their sleep actually closely resembles ours. These animals even have their own versions of REM and non-REM sleep. When in their version of REM sleep, octopuses have beautiful changes in their skin patterns and rapid eye movement. And maybe even dreams. Or nightmares. Some researchers have noticed octopuses behaving like they are under predatory attack during this stage of sleep. Sort of like sleepwalking. Or is that sleep swimming? Although it may appear that these sleep patterns have a common evolutionary origin with humans, our most recent common ancestor with these creatures was hundreds of millions of years ago, and only had a very simple nervous system. That means that sleep patterns actually appeared independently, likely because of similar pressures in the environment. This makes sense, given how common sleep is across the animal kingdom. It's hard to say how many times sleep evolved in different animal groups, but as far as we know, all of our mammal cousins need to sleep. And speaking of how broadly sleep is observed, we can't forget about brainless animals. Yes, you guessed it, sleep-like states exist in creatures like the jellyfish. Even though jellyfish and their relatives only have nerve nets rather than true brains, they still have rest states that could be considered sleep. When jellyfish are deprived of this rest time, they show less activity and responsiveness the next day, much like you feel if you stay up too late yourself. The finding of sleep-like states even before central nervous systems evolved is an amazing discovery, pointing to sleep as something so vital for survival that it arose extremely early in the development of life on Earth. What a great excuse to hit the snooze button the next time your morning alarm goes off. As you can see from this deep dive into the sleep of marine animals, rest in aquatic worlds is truly an evolutionary wonder. From our closest marine relatives to creatures that don't even have brains, sleep has found a way to prevail. It's a great reminder not only about how important sleep is, but also that we have a lot more in common with sea creatures than what might first meet the eye. The jungles of South and Central America are home to a tricky little mimic. These adorable predators rule the treetops with an overly fuzzy paw. This is the most arboreal cat in the world, the trickster of the trees, the tamarin's bane. The Margay. The Margay, or painted cat, is the middle child of the Leopardus genus, fitting in between the smaller oncilla and the larger ocelot. If ocelots are mini jaguars, then Margays are mini ocelots. Ocelots can weigh up to 15 kilograms, while a Margay will weigh at most 4 kilograms. Despite being roughly a third of the size, a Margay can be hard to tell apart from an ocelot, but the big clue is their eyes. Margays have giant puss-in-boot eyes that stand out much more than an ocelot's. While the ocelot's size and adaptability have allowed it to conquer a myriad of terrain, the Margay is a specialist. And their area of choice? The treetops. Margays are one of the, if not the, most arboreal cats in the world. Allowing them to conquer such a physically challenging habitat are a series of evolutionary adaptations. First and foremost, their feet. Jungle trees are full of twists and turns, and only the most dexterous of species are able to navigate them with any sort of skill. It's this demanding habitat in which New World monkeys, with their prehensile tails and opposable thumbs, thrive. Similarly, Margays have evolved their own tools to get around. They have ankles that can turn up to 180 degrees. This, in combination with their sharp claws, allows them to descend trees head first, greatly increasing their agility in the tree canopy. They also have very long tails, which allow them to balance in the treetops, a key tool in hunting their prey of choice. Tamarins, and other New World monkeys. In order to traverse the jungle canopy with any speed, You have to be able to make decisions very quickly and adapt to new situations at the drop of a hat. Branches may not lead where you expect, and prey species may be more familiar with their territory than you are. If you're not smart, they'll outmaneuver you. Margays are very intelligent, and while they are experts in navigating the trees and can jump up to 3.5 meters horizontally, they know that sometimes it's smarter to let the prey come to you. These cats are tricksters. Instead of chasing down prey, they've been known to mimic them instead. One cat was seen mimicking the vocalizations of a baby tamarin, although poorly. And when the adults showed up to see what was going on, it pounced. While the jungle canopy provides a lot of different prey options, like bats, birds, and monkeys, they will venture more into the territory of their larger cousins, the ocelot, when the opportunity is right. This Margay has spotted something moving on the ground. A rat! She starts to make her way down the tree. Having not seen the Margay descending from the canopy, this rat's day is about to get a lot worse. The Margay silently advances. Its massive paws help mask the sound of its approach. She pounces. But this rat isn't going down without a fight. The rat jumps, kicks, and bites, trying to ward off its attacker. It looks like the rat might make it out alive. But at long last, the Margay gets a hold of the rat's neck and crushes its windpipe. A good day for the Margay is good night for the rat. Margays are nocturnal and usually spend their days asleep in the trees, but this opportunity was too good to pass up. With their giant eyes built for night vision and their giant paws built for climbing, it's easy to say that these are the cutest predators in South and Central America. But something that makes them even cuter, their fur. Like their cousins, their coats are covered in dark rosettes and streaks, meant to mimic dappled sunlight on the jungle floor. But they have an added feature. They have extra fuzzy fur, but no one really knows why. In fact, in Brazil, they are colloquially known as gato peludo, which means extra furry cat. Unfortunately, this coat is one of the reasons why they are listed as a near-threatened species. Their coats can be a hot item on the black market, and thus make Margays a popular target for poachers. They also suffer much more so than their less arboreal relatives from deforestation. Massive areas in their range can no longer sustain them or their prey due to fragmentation, deforestation, and urbanization, and their populations are only healthy in the Amazon basin. As we continue to segment their populations by dividing them with roads, farms, and cities, their numbers will continue to decline. Imagine being able to sleep while flying, take a nap upside down, or even use your bum as a pillow. It may sound like a dream, but these are all real ways animals sleep. And these slumber skills aren't just party tricks, they're evolutionary life hacks, helping animals to survive in the unique environments they live in. So we've rounded up some of the most bizarre ways animals sleep. And get ready, because they're about to blow your own sleep score out of the water. All animals with brains need sleep to live. Even some without brains, like worms and jellyfish, need some form of rest. But sleep can be risky business. Nodding off puts animals at risk of predators and takes time away from the daily tasks that help them survive. So they've gotten pretty creative when it comes to recharging their batteries. A good sleep can often start by holding on to something huggable, and sea otters know this firsthand. When it's time to nod off, they lock paws with each other, holding on tight to ensure they don't flow out to sea alone. It's both adorable and functional. Because sea otters live in the Pacific Ocean, they don't often come onto land, and it's their way of staying safe in the strong currents. And if you thought two sea otters holding paws was cute, check out a group of them doing it. The furballs come together to make a floating bed using blankets of kelp and seaweed. These rafts act like anchors in the swirling sea, with up to 100 otters snoozing on them. Now that's what I call a slumber party. For ultimate comfort, they also bring their built-in sleep masks to the party, using their paws to block out sunlight, making it easier to rest. These aquatic members of the weasel family have some of the most iconic sleep postures out there, allowing them to rest for about 11 hours a day. By keeping their paws out of the water, they reduce heat loss and conserve energy. Kicking back in nature's waterbed not only looks serene, but also helps keep them away from land predators like wolves and brown bears. When gently resting, sea otters sometimes roll over face first into the water. As you can imagine, it's a bit of a rude awakening when they realize they need to breathe, and quickly spin back over. But if they're in their deepest stage of sleep, paradoxical sleep, they can dunk their heads in the water and keep dozing for almost a minute. Now, technically, this episode is going to focus on land animals, but these marine mammals are just so famous for their sleep, we couldn't leave them out. But if you're wondering more about how marine animals sleep underwater, we did a whole episode on it, and it's mind-blowing. Check it out in the link. Animals have evolved many ways to improve their sleep and help their brains recover. It's a necessity of life that we share with them. Sleeping while overheating is almost impossible. So how do animals endure some of the hottest places on Earth? This is the Negev Desert, home to the white desert snail. When there's not a drop of it in sight, these snails simply hit the pause button of life and can sleep for several years. Talk about a snooze button. The prolific nappers have evolved in some of the driest and most extreme conditions on Earth. So when the environment is too harsh to be active and they can't leave, all they can do is wait. For months. To do this, the snail retreats into its shell and seals off their opening by secreting a dried mucus sheet called an epiphragm. Think of it like nature's version of a thirst-quenching face mask, locking in moisture to prevent dehydration. Once on lockdown, they slow their heart rates, metabolisms, and energy use so they can survive without food and water for incredibly long periods of time. Their seal keeps water from evaporating and keeps the snails moist. So how does a desert snail know when to wake up? It uses rain as an alarm clock. When it rains, the water dissolves the dried mucus barrier. This lets the snail know that they can finally rehydrate and go about their day. And let's be honest, waking up to a rainstorm sounds much more fun than being jolted awake by the bad phone alarms we use. The way animals like desert snails ride out extreme heat and drought is called estivation. It's not quite sleep, and not totally a break from life, but a prolonged stage of dormancy, like a superpower for fighting the elements. Some reptiles and amphibians faced by extreme heat also estivate, like desert tortoises, crocodiles, and some salamanders. And if you think this way of beating the heat to sleep is amazing, just wait until you hear what some frogs can do. They literally freeze to sleep. To survive the harsh winters in Alaska and northern Canada, North American wood frogs freeze themselves to sleep and ride out the season. These are places where the temperatures dip to around -45 degrees Celsius, so these guys just go full frogsicle. The biological miracle starts as ice forms inside the frogs' abdomens and surrounds their internal organs. Then, ice crystals build between the layers of muscle and skin. Even their eyes turn white as their lenses freeze. Eventually, there's no muscle movement, heartbeat, or breath, and these frogs become frozen ice sculptures of themselves. But while this is happening, the frog's liver pumps out glucose. This kind of sugary syrup acts like a biological antifreeze, preventing the cells themselves from freezing solid. This stops the froggy from freezing to death. When spring arrives and the cold plunges are over, wood frogs thaw themselves from the inside out. We don't know exactly what kickstarts the frogs' hearts, but once they come back to life, they spring back into action. It's now time for breeding, and the frogs make their way to ponds, getting busy making tadpoles to become future ice kings and queens. Wow, these frogs got me thinking, maybe next winter I'll just copy them and turn into an ice gargoyle until it's warm again. With these kinds of sleeping superpowers, it's no wonder humans are envious. We've been fascinated by the idea of being able to freeze and revive ourselves years later. For now, it's only a sci-fi concept, but there are some animals who can do a version of this in nature without any kind of lab. It's called torpor, and you can think of it like hitting power saving mode on your cell phone. During winter, many mammals take short, involuntary breaks to survive food shortages and harsh weather, in a process called torpor. During torpor, animals dramatically drop their body temperatures and suppress their metabolisms. It's usually short-term, but when it goes longer, it's called hibernation. Like these adorable dwarf lemurs of Madagascar. Amazingly, their heart rates drop from over 300 beats per minute to less than 6 when hibernating. But it's the European edible dormice who take the cake for longest hibernator at 11 months. And I mean take the cake literally. It has to fatten itself up to double or triple its weight in the time it is active to prepare for its long nap. These chubbies were even a luxury meal for ancient Romans, and are still eaten in the Balkans today. Now, these dormice don't just hibernate because it's chilly out. It's a lot more fascinating than that, and has to do with how they make babies. Every summer, when these plushies emerge from hibernation, they have two goals: to eat and to mate. Once their babies are weaned, these little ones need to get fat fast. But there's a problem. While adults can chow down on leaves and fruit to put on weight, babies need a richer food source, like seeds. And some years, trees don't yield as many. Amazingly, the moms can sense when it's going to be a bad seed year. And when they do, they can actually pause their pregnancies, delaying the implantation of the embryo in their uterine wall until conditions are better. An average litter of dormice is 7, and incredibly, a mama can reabsorb these fetuses. Then she gets back to the business of feasting to get ready for 11 months of hibernation to try it all again next year. Torpor and hibernation are both energy-saving states, but hibernation takes place over a more planned-out seasonal period. Both of them are different from sleep, because during hibernation, brain activity slows to almost a standstill. But during sleep, brain maintenance is carried out. So surprisingly, hibernators actually have to wake themselves every once in a while to catch up on sleep debt. Hibernation helps animals hide from extreme weather, keep them safe from predators, and lower nutritional needs during times of scarcity. These echidnas actually hibernate after fires, waiting for food to rebound. It helps them with protection from predators. Take this chipmunk as an example. When hibernating, it doesn't make any noise, sudden movements, or give off any smells that may alert its predators, like foxes or coyotes, to its whereabouts. These facts about animals are anything but sleepy, and while some of them like their beauty sleep,
Others can sleep with one eye open. That's right, it's not just a Metallica lyric. It's how some mallard ducks actually sleep.
To protect themselves from becoming sitting ducks, these birds keep one of their eyes open for predators while taking naps. Incredibly, they're able to do this because while half of their brain sleeps, the other half stays awake. A process similar to that of dolphins and whales, called unihemispheric sleep. To understand why they do this, researchers watched ducks in tanks sleeping in rows. With just a single eye open, the birds on the ends reacted to a slide of predators in less than a fifth of a second. And when shown a video of the group being attacked, these guard ducks wasted no time and instantly sounded the alarm to their friends. But what led these ducks to develop this fancy feat of sleep? Part of it has to do with their massive populations. Mallards are everywhere. If you go outside, they're the most likely duck you'll see. Their success comes from their adaptability to the different wetlands they call home. But their abundance also makes them a good meal. Young ducklings are especially vulnerable to fish, snapping turtles, and bullfrogs. And adults have to deal with hungry foxes, coyotes, hawks, and even humans. Because of their deliciousness, abundance, and catchability, less than 50% of mallards survive their first year.
To help with their chances of survival, mallards stick in flocks, rotating their positions in the sleeping line and heading to the calmer middle when they need a deeper rest. The ducks on the side sleep with one eye open, with half of the brain staying awake and the other going to sleep. But the ones feeling safer in the middle get to shut down both hemispheres. Next time you get a good night's sleep, you can say that you slept like a center mallard. Most people won't know what the heck you're talking about, but fellow Animalogic fans will know.
What mallards do to sleep on the surface of the water is fascinating, but what some of their cousins do in the skies is out of this world. Meet frigate birds. These frequent flyers can stay in the air for an incredible 2 months without falling from the sky. One was even tracked clocking 54,000 kilometers on a single trip. That's like flying round trip from London to New York 5 times without stopping for a nap. They're the Energizer Bunny of migratory birds. They even got their name, frigate, because Europeans thought they looked like strong, swift warships. But how do they take these long-haul flights without a sleep break? Unlike flying a plane, there's no autopilot button to hit when you're a bird flying across an ocean. On top of that, they can't swim, so they can't nap while floating on the water like a seagull or a duck.
So here's their secret. They sleep in 10-second bursts. That's right, these micro naps add up to about 45 minutes a day. It's an amazing adaptation, letting these birds push past the standard rules of exhaustion. Interestingly, the researcher who made the discovery is the same one who studied those mallard ducks. Suspecting the frigate birds must be sleeping in some kind of formation, he and his team wired up 15 of them with tiny electrodes on their heads to measure brain activity and sleep. Because of this, scientists think taking a closer look at how these birds sleep could one day help us better combat our own grogginess.
Like with the ducks, the researchers found the frigate bird brains never go completely on autopilot, and also keep half of their brains active while the other side sleeps. At half power, the birds don't stay fully awake either. At night, when gliding high in the air, they can go into a deeper state of sleep. But when they need to keep awake enough to maneuver in the air, they sleep by napping with half a brain at a time. Since frigates have almost no natural predators in the sky, researchers suspect this split focus is less about danger and more about staying alert to avoid any mid-air collisions. The skills of frigates and other migratory birds like swifts, sandpipers, and songbirds are amazing because they challenge our idea of sleep as an all-or-nothing binary state. Unlike humans, who have fairly strict circadian rhythms, birds are much more flexible when it comes to their body clocks, bending their sleep and wake cycles quite literally on the fly, based on their environmental needs at the time.
The concept of unihemispheric sleep is weird, but a bit easier to understand if you think of their brains like a city. Instead of the whole city shutting down at night, neighbors take turns dimming their lights and doing maintenance to keep it running efficiently. In other words, clusters of neurons in the brain can recharge while the rest of the operating system stays online.
The way this works in birds may also have some interesting parallels in humans. You know those types of restless nights where you struggle to get a good sleep, especially at a new location? Researchers are looking at whether this may be a mild form of unihemispheric sleep, with half of our brains staying more vigilant and alert throughout the night. It makes sense, but don't go trying to fly across an ocean anytime soon, because we still can't fully sleep with half our brains awake.
From the skies to the savannah, the weird ways animals sleep can sometimes soar past belief. And we couldn't do this episode without telling you how the tallest mammals on Earth are also the shortest sleepers. Giraffes.
Let's start with baby giraffes, who hit the hay on nature's best pillow, their own rumps. In this pretzel position, these little guys and gals become contortionists, twisting their legs underneath themselves and resting their heads on their bums. This keeps their vulnerable bodies protected, but also leaves their head at a height where they could spring up quickly if they needed to. Adults sometimes do this too, but much less often. Getting into that position is a lot harder once you've grown over 5 meters tall. Instead, they opt for standing naps, and only in short bursts, usually just a few minutes at a time. In total, giraffes may only sleep about 20 to 30 minutes a day. There's 2 main reasons giraffes are thought to sleep so little. 1, the leaves they eat don't have a lot of nutritional value, so they have to eat 24/7. And 2, their neighbors are hungry lions. They have to be ready to bolt at a moment's notice to keep from becoming a meal.
When wild giraffes finally do let themselves nod off, they use the buddy system. While some community members sleep, others stay on watch, keeping an eye out for their pals. This style of taking turns while sleeping lowers the danger of being attacked. Lots of other herd animals do this too.
African elephants, zebras, deer, and even cows do watch rotations, so no member of the pack ever gets too sleepy.
So we've now journeyed into some of the weird ways around how animals sleep, but where they sleep can be just as quirky. There's some pretty interesting evolutionary factors at play when it comes to the places animals like to hang their hats, with some of them literally just wanting to hang out.
Bats like to sleep upside down in roosts, safe, dark places where they can curl up together. Because they don't build nests, their homes can be made in attics, caves, bridges, or hollowed-out trees, and keep the bats safe from predators and the weather. They can sleep for up to 20 hours a day, and while it may look topsy-turvy to us, it's the position they find most relaxing and uses the least amount of energy. Because it's better for flying animals to have lightweight legs, putting a bunch of heavy weight on them in an upright position would be uncomfortable. And unlike birds who lift into flight, bats prefer to fall into flight, so being upside down makes it easier for them to take off quickly. Bats prefer to take to the skies this way because they don't have hollow bones like birds do, and it's hard to get as much lift from the ground. Other social sleepers are meerkats, who cozy up to keep warm in groups in underground burrows, complete with sleeping chambers fit for a queen. No, seriously, the queen of the group sleeps in the middle to get the best sleep possible. And for good reason, the queen is in charge of reproduction, while her subjects help raise the young. When summer hits, some of them will come above ground and spread out a little more while sleeping.
These meerkat mobs take no prisoners when protecting their own. Living in the dry regions of southern Africa, life is harsh, and so they have evolved in a way similar to social insects who have a single matriarch at the top of command. Burning the midnight oil, digging up all these stories about animal sleep got us thinking. Does the way we as humans sleep in beds have a connection to the animal kingdom? Of course it does! And not surprisingly, it's a family thing that starts with our cousins.
Today, many chimps sleep in treetop nests, similar to bed-like structures. This behavior likely evolved because nests led to better protection, making for a deeper and longer sleep. The concept of using a bed is so common, we sometimes forget what a relatively new and game-changing adaptation it's been. Beds helped shape the course of history by allowing better sleep, which was needed to support the demands of more complex brains.
But here's the catch. Trees don't always offer a restful slumber. Everything from winds, tree snakes, and other rowdy primates can wake these animals from their slumber. So some of them started to sleep on the ground for a more restful sleep.
Early humans are thought to have been sleeping on the ground around fires around 2 million years ago. This helped them sleep more deeply and safely than in trees, and it might have led to more REM sleep and increased brain development. The positive benefits then snowballed, with better quality sleep allowing humans to get by on shorter amounts of it, allowing for more time to learn, be social, and defend their communities.
So, your pillow has a lot more history than you might think. And if you need something peaceful to think about when falling asleep tonight, here are some honorable mentions for incredible sleepers.
Koalas hold the title for longest sleepers, catching up to 22 hours a day. Because their diets rely on eucalyptus leaves, which are low in nutrients, they need to do everything they can to conserve their energy. Male solitary bees take the prettiest sleeps in all the land. They use flowers as bachelor pads and have a hunch for knowing which petals their females prefer. How romantic! And snakes, well, they don't have to close their eyelids to sleep because they don't have them. Instead, they have a clear membrane that covers their eyes to protect against debris and scratches.
The way animals sleep is fascinating, but this has been a lot of excitement for one day, and we're getting ready to hit dreamland over here. But on the topic of dreaming, we had to wonder, can animals do it? While we can't ask them directly, we can make some observations.
Animal dreams seem to be connected to what they might experience during their waking hours. Like sleeping cats, who seem to behave in the same ways as if they were chasing mice in real life, moving their heads as if they are tracking something. It's thought dogs also live out the same kind of chases in their dreams, like darting at that squirrel it saw earlier in the park. In studies on rats in mazes, scientists discovered the same brain patterns when they were awake and asleep. This suggests the rats may be replaying their adventure through the maze in their dreams.
Rats, they're just like us. And honestly, who hasn't played out the activities of their day in a mind-bending dream? I'm constantly reliving all the times our producer Andreas asks me to do another take. Just kidding, Andres. Every day, we learn more about how animals catch their Z's. And there's going to be a lot more where this came from as new scientific discoveries are made about why these incredible creatures sleep the way they do. So what should we talk about next? Please let me know in the comments, and don't forget to subscribe for new episodes every week. Thanks for watching, and sleep tight!
Animals give us squad goals. Their social bonds are equal parts aspirational and adorable. And in some species, their communities are so tight-knit that when one of them dies, others take notice. Around the globe, elephants are holding vigils, magpies are burying their fallen comrades, and whales are clinging tightly to their lost calves. These death rituals are fascinating, and sometimes look a lot like our own, raising a big question: can animals have funerals? And if they do, what could be the meaning of them? To simply wave goodbye, or is there something deeper going on? It makes you wonder, do animals grieve?
Saying goodbye to a loved one is never easy. We Homo sapiens use the word grief to describe the intense emotional and physical pain we feel when we lose someone important to us. But what if we're not the only ones who feel it? We can't ask animals what they're feeling, but we can watch how they respond when one of their own dies.
Time and time again, they don't just walk away, they linger, investigate, and appear to hold ceremonies for their lost souls. It's hard to not anthropomorphize these events, meaning putting our human lens and emotional interpretation on them. But however we perceive it, there's no denying animals show great interest in their dead.
So in this episode, we're exploring what might be driving this ceremonial behavior. And though there's a natural element of sadness to loss, we're looking at these events as moments to celebrate the beauty of social connection in the animal kingdom. Because as the saying goes, 'tis better to have loved and lost than never to have loved at all.
So let's start with one of the most captivating send-offs ever, proving love can be as deep as the ocean. Meet Tahlequah, one of the most devoted whale mothers of the sea. In 2018, off the coast of Canada's Vancouver Island, this killer whale, or orca, took a tour of grief when she refused to let go of her newborn dead calf for an awe-inspiring 17 days. The world watched as she swam an incredible 1,600 kilometers, balancing her daughter's body on her own until she finally got the courage to say goodbye.
The event captured hearts and minds everywhere to deeply ponder the emotional connection animals may have with their dead. It was also a reminder that killer whales are also loving whales.
We don't know what caused the calf's death, but it's thought she was only alive for less than an hour. Scientists believe whales can recognize when a calf is dead, so Tahlequah's behavior can be interpreted as a vigil for her lost daughter, expressing the bond between mother and child. Amazingly, Tahlequah was spotted doing the same thing again in 2025 when she lost another calf, this time off Washington State's northwest coast. Also a daughter, she carried her for 11 days.
This social bond between killer whale mothers and their offspring is one of the strongest in the animal kingdom. These are rock star moms, completely dedicated to the survival of their calves, giving up months, sometimes years of their lives to make sure that their family lineage survives.
Killer whales are highly social creatures and mostly live in groups of pods closely connected to their moms and grandmas. Sticking in groups increases their chances of survival when it comes to hunting and sharing knowledge. They do this using complex vocalizations like clicks, whistles, and pulsed calls. Passed down in their pods through generations, they form unique acoustic clans to recognize their loved ones' calls. Wow, talk about love language!
Because of these close ties, it's not unusual for a mom to carry a dead calf. But the large amount of time and energy Tahlequah spent on carrying her dead made scientists take notice. It's risky behavior because she couldn't hunt for food while balancing her daughter on her body. Luckily, Tahlequah wasn't alone. Back in 2018, during her heartbreaking journey, her own mother, Princess Angeline, stayed right by her side, but has since passed away. And in 2025, her sister Kiki, known for her sharing her food, was spotted close by. Needless to say, we here at Animalogic will be sending Tahlequah a #1 Best Whale Mom badge stat immediately. She deserves it.
Tahlequah's viral story is just one powerful example of a bigger observation in cetaceans. Marine mammals like whales, dolphins, and porpoises who have shown grief-like tendencies for their dead. Being together is part of their nature, and it's pretty much the same for us, even for meals. Everything is a little easier when you're around your friends and family.
So, could these acts be funerals? Considering many cetaceans have highly complex brains and cognitive functions like problem-solving, self-awareness, and advanced learning, it's not a stretch to wonder if they could be experiencing grief. These same types of traits are linked to how humans process emotions. But we still have to be very careful with how we interpret these behaviors. There are some cautionary tales.
In one famous scene of grief in Australia, a male kangaroo holds the head of his dying mate. Aw, looks sweet, right? Not so fast, say some scientists, who have pointed out he may have just been feeling frisky. Skeptics say the kangaroo was likely attempting to mate with a female while keeping other males at bay, which is, less sweet.
The jury is out on this one, but it shows us how much we still don't really know about how non-humans perceive death. The name for this field of research is called comparative thanatology. It's relatively new, but totally fascinating. And one of the most famous case studies in the field starts with our closest relatives.
Chimpanzees are known for a lot of things. They're highly intelligent, resourceful, and social, but they're definitely not known for being quiet.
So when 16 chimps went completely silent at a rescue center in Cameroon as one of their dead was taken away, the moment was unforgettable. The chimp was Dorothy, a maternal figure in her 40s and a dearly beloved friend of fellow rescued chimps at the center. When she died of congestive heart failure, her comrades looked on as if attending a funeral march. Dorothy had become more than just a member of the group. She took on a motherly role to an orphan chimp named Babool and became BFFs with many others. A volunteer at the center said her loss visibly rippled through the other chimps, and their recurring silence was stunning. At the same time, some of the members seemed to express anger at the situation, showing aggression and barking. Denial, anger, it sounds familiar. Could these have also been stages of grief for the chimps?
A viral photograph of the moment sparked a big conversation between the public, scientists, and philosophers about what these chimps may have been feeling. And Dorothy's passing became a key event in getting us talking about whether animals can mourn. Looking at how other primates have responded to death gives us some clues. In Rwanda, the separate deaths of 2 mountain gorillas in the same social group evoked some adoring responses from their circles. First was the death of Titus, a dominant silverback mountain gorilla who was reported to have been visited by members of his troop after he passed away. Part of the group of mourners was Tuck, a dominant female. About a year after the loss of Titus, she weakened and passed on. Her son, Segasira, stayed with her corpse, gently touching it and even trying to move her head. He also groomed her and attempted to suckle on her body even though he had already been weaned. It looked like the loss of his mom affected him deeply. Primates are social butterflies that love physical touch and their cuddle puddles. Mutual grooming builds trust and reliance for emotional well-being and reproductive success. So it's not surprising that those left behind wanted to stay in close contact with Titus and Tuck.
But not every reaction was calm. Like in the case with Dorothy the chimp, some of the gorillas showed what seemed to be hostility at losing their friends, beating their chests, kicking their bodies, and screaming out. Interestingly, these types of reactions in gorillas don't stop at members of their same social group.
In the Democratic Republic of Congo, researchers spotted a pack of silverback growers gorillas coming upon a dead member of their species, but unknown to their group. Instead of passing it by, they started circling the body and grooming the remains. This event is special because gorilla societies are typically very protective, and outsiders are seen as rivals to be avoided or met with aggression.
We can only wonder what motivated these gorillas' behavior. But it's a very interesting phenomenon since such close contact with corpses could make them sick. So scientists are still trying to figure out from an evolutionary perspective why animals would invest time and energy interacting with dead animals that could be a health risk. Right now, we don't have a firm answer to the question, but are starting to get more clues. And one of these hints comes from an iconic folklore symbol of death itself: crows.
In Celtic mythology, crows are often seen as messengers from the underworld, birds that can sense when death or war may be imminent. But beyond the myths, their real-life behavior when it comes to death is just as captivating. When a crow finds a dead member of its own kind, it sounds off an alarm call, summoning its flock for a crime scene investigation. Any other crow detectives in the area swoop in, and in a big, rowdy mob, the autopsy gets underway. After about 15 to 20 minutes, the crowd of crows disperses and goes about their day. I don't know about you guys, but that sounds more interesting than a CSI episode to me.
Scientists think there's likely a method to this madness, that it's a learning opportunity to share information about new threats in the environment and know what dangers to avoid in the future. It's like survival training in action, danger and avoidance 101. And when it comes to recognizing threats, crows are masters of memory. They're very smart, with big brains for the size of their bodies. So smart, they can even remember the faces of threatening humans and hold grudges for up to 17 years.
Researchers from the University of Washington made this remarkable discovery while studying American crows.
The story starts with a caveman mask. No, seriously. Back in 2006, the lead researcher wore one while tagging 7 crows before their safe release. Later, when that scary mask was worn again, the crows didn't forget. They sounded the alarm to their friends and dive-bombed the researcher. The dive bombers were a squadron of dozens more crows than the original 7 that were tagged, suggesting information about this scary-looking human was shared among the flock. Okay, but what does all this mask business have to do with funeral rituals? In follow-up experiments, the researchers got the birds together by drawing them in with food. Then, a person wearing a mask carried a dead crow into the area, and the person was dive-bombed and scolded and yelled at by the birds.
Later, if they returned in the mask, even without a dead bird, they were also dive-bombed, essentially guilty by association. The crows were also less likely to be lured, even by a snack, as the area became associated with danger. So while these crow funerals may not be about who can give the best eulogy for their pal, they are highly effective gatherings to learn about death. Crows belong to a group of smarty pant birds called corvids that also include ravens, jays, rooks, and magpies.
There's also reports of magpies being pallbearers. One animal behavior ecologist even watched as they gathered for a burial. After one of the birds had been hit by a car, 4 of its flockmates laid eyes on the open casket before returning with twigs and pine needles to lay near their buddy. The group stood in solidarity before eventually flying off. And as the saying goes, birds of a feather flock together. The same is true of serial monogamists, penguins.
In one extraordinary case at Sydney Sea Life Aquarium, a Gen 2 penguin named Sven got a remarkable send-off in birdsong after he died at age 11. The ditty was led by his partner Magic and a choir of their penguin friends. Sven and Magic captivated hearts everywhere after making headlines as a same-sex couple and raised 2 adopted chicks together. In the wild, when a penguin dies, it can cause confusion for the partner left behind, and they can go searching for their lost loved one. But in this case, aquarium staff showed Magic what happened to Sven, prompting his eruption into song.
Staff saw it as a sign of how powerful their bond was. A love story started the same way a human relationship might, through courtships. Magic and Sven, like other penguins, would bow their heads and sing to each other to build a connection, and then offered each other a rock. No, not an engagement ring, but a pebble. Gen 2 penguins are known to search for the finest stones to give to each other, to build their nests together. How sweet. The emotional bond of penguins reaches all the way from Australia to Antarctica, the home of the emperor penguins.
These brave animals are the only species that breed during the frosty Antarctic winters. Females can only lay 1 egg per season, and they don't even use a nest. The males carry the eggs precariously on their feet. These penguins sacrifice a lot to become parents, meaning their attachment to their chicks is very strong. So if one doesn't make it, it's a devastating loss.
When this has happened, companion penguins have been seen stepping in to console the grieving mothers. One friend even placed her head on the mother's head in what looked like a scene of camaraderie in the face of tragedy. These heartfelt funeral scenes kind of makes you wonder, if animals can mourn for emotional reasons, Might there be an evolutionary advantage for it? Even the Big D, Charles Darwin himself, pondered this idea in The Descent of Man and questioned, who can say what cows feel when they surround and stare intently on a dying or dead companion? If we look at us humans as an example, grief has deep evolutionary roots, and awareness of death can be seen as one of the defining traits of Homo sapiens.
Psychologists believe our feelings connected to loss may have started when our ancestors became more social and started relying on community and cooperation to survive. And as our social bonds got stronger, so did our emotional attachment, shaping our ability to love and also feel pain when we lose someone close.
The way we bury our dead reflects these bonds. Humans have been assigning meaning to death since ancient times, and our funerals have gotten ever more elaborate with every passing century. These rituals don't just honor the dead, but bring together the people left behind, acting like a support system when we're at our most vulnerable. Though they can be sad, they reinforce our social ties. And if our emotions are shaped to help us survive, could it be the same with animals?
One species that's known for being huge emos are elephants. You may have even heard that they can cry. Well, they can shed tears, at least. While they don't have traditional tear ducts like us, they have temporal glands behind their eyes that can create excretions when they're excited or stressed.
Those scientists think these tears are for lubricating dry eyes rather than emotional response. So, you might not see an elephant crying into their beer and writing a really sad country song anytime soon. But they have been seen holding some of the most iconic vigils around. When it comes to how we study animal grief, they're pretty much the gold standard because of the number of times we've seen them do this in the wild.
Elephants gather around dead bodies of their own, often in a solemn and quiet way, touching the bones with the end of their trunks. And if the elephant is familiar to them, they call in members of their herd to come join the vigil. A gathering ensues, with some elephants stroking and caressing the bones, or scooping up sand and throwing it on their fallen. Some elephants even kick logs as if they're trying to release something they can't express. Their powerful sense of smell helps them sniff out when a friend or family member has died. This is because when an elephant's body starts to break down, changes to its chemical composition make it smell different, and other elephants can detect it from a distance. African elephants in particular have the best noses of all mammals, and can even smell water up to 20 kilometers away. This and their tactile sense of touch gives them an understanding of what has happened, and that it's time to let go.
When it comes to elephants, there can even be state funerals, where members outside of the same herd pay their respects. So it's no coincidence that Queen Victoria, one of the last surviving matriarchs of an elephant group in Kenya, got a royal send-off. Even members outside her community made the trek to come see her body. One of the most fascinating things about this is how long the elephants stood around for. Elephants have to feed for about 20 hours a day to get the nutrients they need, and every minute counts. So, the time they took to stand around the body came with a direct cost to them. Yet, they chose to do it. Each of them personally gave up something to fulfill these rituals. So there's definitely something bigger at play here. And it's not only big guys that have death rituals. Insects can be grim reapers. Though well-intentioned for the survival of the group, their death rituals are a little more like a cleanup crew at work.
With insects living in such close social quarters, there's no room for delay when it comes to dealing with dead corpses. Bacteria and fungus can spread fast, so when an insect dies, it's dealt with immediately, without any pomp and ceremony.
And while it may look as ruthless as a Sopranos episode, it's a form of preventative medicine to stop other insects from infection.
In honeybee colonies, an undertaker bee snatches corpses in its jaws and drops it outside the hive.
Termites act as quick grave diggers and deal with their dead by burying them right into their nest. They detect death through a chemical change and move quickly. The eastern subterranean termite deals with its dead corpses in a matter of minutes. And risk plays a role. If the dead termite was from a related but different species, 10 times as many termites pitch in with the burial. More perceived risk means more resources on cleanup duty. Ants, on the other hand, have cemetery staff standing on duty.
When one dies, worker ants carry it to a designated graveyard to save the colony from risk of disease. And in colonies that haven't formed yet, the queen of the black garden ant takes matters into her own hands, burying fellow fallen queens herself.
All this is happening every day, right in your backyard. But what goes on inside of our homes? We've been talking about wildlife, but what about domestic pets? Do they grieve? There's been many stories of dogs mourning the loss of their owners, even attending their funerals. In 2014, a German Shepherd service dog named Danny stood and whimpered next to his owner's casket, who was killed in the line of duty as a Canadian police officer. The story made international headlines, reminding us the powerful connection between us and our pets. But do pets mourn the loss of each other if they share the same homes? Behavioral changes to routine may suggest yes.
For households with more than one pet, dogs can respond to loss in noticeable ways. They may stop eating or drinking, search for their lost companion, or even bark to show their stress. Now, they may not know that their best bud has died, but they can clearly sense that something is different or missing. Incredibly, dogs can also sense when we are grieving. Because dogs are genetically wired to bond with humans, they can pick up on our stress levels. Researchers have even scanned dogs' brains on MRIs and found that their cortisol levels, a stress hormone, rises when ours does. Dogs do this by detecting subtle changes in human body odors and our hormones produced during grief. And in turn, these chemical cues influence our pet dog's own psychological and emotional states. No wonder they're called our best friends.
Now, this human-dog connection may have got you thinking, can animals of different species mourn each other? It's more rare, but there have been some incredible sightings. An elephant was seen mourning the loss of a buffalo as if it were her own, after being killed by a pride of lions. And a famous case in 1984 showed Coco the gorilla expressing sadness when her pet kitten died. Researchers had taught Coco sign language, and she kept signing sad after her kitten's loss. This journey into animal funerals hasn't been easy, and neither is loss. But maybe that's the point. Because watching how these animals react to death makes us think deeper about the roles they play in life, showing us just how complex, sacred, and beautiful their bonds with each other and us can be. Whether we call it grief or something else altogether, these moments of connection are real, and they give us a fascinating peek into the emotional lives of animals. It's a completely new frontier we're just beginning to discover, meaning lots more to explore in our future episodes. And before we wrap this one up, we couldn't finish this episode without mentioning some animals who aren't known for visiting their dead, but playing dead. Known as apparent death, it's a survival strategy animals use to mimic a dead corpse and ward off predators. We've done a whole episode on it, looking at everything from ants to desert beetles, snakes to sleeper fish, but none are better tricksters than these critters.
Ever heard the phrase playing possum? Turns out, it's not just a saying. When threatened, opossums play dead. On the spot, they keel over, go limp, foam at the mouth, and leak pee and poop to mimic a dead, decaying animal, helping predators pass them over in favor of something, cleaner? These award-winning actors are the only marsupials in North America. And though they give Oscar-worthy performances, possums aren't even aware when they do it. The reflex is an automatic, involuntary response to extreme fear. Kinda like how humans can faint under stress.
So there you have it, the final curtain on this last act. But the show will always go on, and we hope these stories of animal funerals have left you with something special to remember.
If someone calls you bird-brained, they're probably trying to say that you're a little slow. But considering all we've learned about how smart some birds really are, this may not be the read your bully thinks it is. Let's dive bomb straight into the brains of crows. Are they as smart as they say? Or do people just think they're deep because they're goth? Today we're asking the question, are crows smarter than a 5th grader? You could go pretty much anywhere on Earth and you'd find crows. Their sleek black feathers make them stand out whenever they land, and their dashing wings cut a majestic figure when they're airborne. These icons sometimes represent death, the story behind naming a flock of crows a murder. But they're also associated with power, evolution, and trickery. Almost every mythology and culture in the world has some unique tale or origin story about crows. But why is that? Why do they fascinate us so much? Their main thing is their famous advanced thinking powers, but even that is selling them short. Did you know that crows are also incredible mimics? They've been trained to count up to 7, with the most verbose among them being able to say over 100 words and 50 full sentences. Without having heard it, what do you think they'd sound like? I think they'd sound like this. 1, 2, 3. Some pet crows can even mimic their owners' voices to mock the family dog and torment the livestock. Their rap for being tricksters is definitely earned. On the flip side, crows are also known for their soft side, bringing gifts of shiny objects and stones to humans that feed them and treat them kindly. Crows and their corvid brethren are some of the smartest non-primate creatures on planet Earth, at least in the way the primates are smart. Depending on the study, their intelligence has been compared to that of a smart gorilla, a dumb Neanderthal, or an average 7-year-old kid. Crows have been the focus of studies on bird intelligence because of their remarkable natural abilities, like fashioning tools to get a tasty snack, leading us humans to personify them. That's because we humans love to use ourselves as the bar, leaving us to wonder, how smart are crows compared to us? But before we can truly determine what groups of creatures, or humans for that matter, are the best analog for crows, we need to talk about intelligence in general, at least as we classify it from our human perspective. We have to keep in mind that human intelligence evolved to help us with our own specific needs in our unique environments. Other species have their own challenges to overcome, so intelligence from species to species won't always mean the same thing. Flighted birds, for example, navigate life in the air, where every direction, up, down, side to side, has potential for movement. Without assistance, humans are bound to a single plane, moving back and forth, side to side. Imagine how that must impact a bird's spatial perception, and therefore, their brain development. Having said all of that, if we're going to figure out who's smarter, a 7-year-old human or a crow, we need to measure their smarts with our own yardsticks. But even the question of what it means to be smart is a huge mystery. There's a lot of debate, but no consensus. We, the very humans who are comparing ourselves to other animals, can't agree what intelligence actually is. What we can agree on pretty universally is that human intelligence is a psychological construct, a concept we've put together to explain something we can't observe. One generally accepted definition of intelligence is the ability to reason, plan, solve problems, think abstractly, comprehend complex ideas, learn quickly, and learn from experience. So let's see how the crows fit into that. Let's start at the beginning and ask the question, can crows reason? A 2012 study on New Caledonian crows set out to answer just that. Let me take a moment here to talk for a second about New Caledonian crows, since we'll be hearing a lot about them in this episode. They're considered among the most intelligent of all the crows, and are therefore studied more deeply than other species of corvids. They're the nerdiest member of the nerdiest bird family, and of course, they perform really well on standardized tests. In this study, the researchers wanted to know if crows can figure out cause and effect if the cause is hidden, which would show reasoning, an ability that was thought to be uniquely human. In other words, if they started watching a movie halfway through, could they figure out how it started? The study gives the example of seeing leaves moving erratically in a thick canopy. We can deduce that there must be something heavy moving around in the tree and shaking the branches. But this understanding of the hidden cause of an action isn't a given for other species. In the experiment, 8 crows watched 2 series of events. In the first, a human entered a hide next to a crow feeder. Then a remote-controlled stick was waved around the feeder, and finally, the human exited the hide. In the second, the stick was moved without the human entering or exiting. The stick was set up very close to the feeder, so the crows could see that they might be hit by the stick if they were to go for a snack. In the case when they saw the human enter and exit, they approached the box less cautiously. When it was unclear who or what moved the stick, and if it might move on its own again, the crows proceeded with caution. This shows some pretty advanced reasoning on the crow's part. Good work, guys. Next up on our checklist of human intelligence, we have plan, which requires a key mark of intelligence, imagination. Most animals are not able to map out their next few moves into the future. but studies have shown that crows are planners, just like us. One study published in 2019 by researchers at the University of Auckland in New Zealand showed that New Caledonian crows are able to plan several steps ahead to get what they want, a bit like a chess player thinking through future moves. In the experiment, the crows were given a multi-step puzzle that required them to use tools in a specific sequence to reach a food reward. Crucially, the different parts of the puzzle were hidden from each other, meaning the birds couldn't simply react to what they were seeing in the moment. Instead, they had to remember where different tools were and mentally plan how each step would help them solve the next one. The setup also included red herring tools that looked useful but wouldn't actually help solve the problem, to test if the crows could ignore bad options and stick to a plan. Many of the crows successfully solved the entire sequence on their first try, suggesting they weren't just learning through trial and error, but were actually mapping out the steps in advance. Yep, sometimes I walk into a room and I forget why I'm there. And while I'm doing that, the crow outside my window is already planning its next heist. But planning isn't everything. Sometimes you need to think on your feet. That's where the unique ability of New Caledonian crows and their ability to solve problems without a plan steps up. Another study set out to understand if crows solve problems with insight, visualizing different outcomes, or through a feedback loop of trying something and seeing if what they're doing is working. In this case, the crows were tasked with pulling a string horizontally to get a treat. Since the string had slack, pulling on it didn't immediately move the treat closer, so the birds didn't have that instant visual feedback with each pull. Almost none of the crows completed this task successfully, showing that they rely on visual confirmation to problem solve. To the credit of the crows, chimpanzees also didn't perform well with a similar experiment. Speaking of primates, we know through studies over the last 30 years that crows actually have cognitive abilities on par with our cousins. That's because their brains have similar characteristics to primates, despite having a completely different brain architecture. Bird brains lack a cortex, the outermost layer of the brain, and the part that looks all lumpy and bumpy. In your brain, the cortex is responsible for a lot, including thinking, memory, language, consciousness, and integrating complex information from all across your brain. Primate neurons are arranged in layers, while crow brains are organized in nuclear clusters. Because of these clusters, crows actually have even more neurons than primates and show similar abilities. And that's all without having a cortex, which was long believed to be the pinnacle of cognition. Okay, let's go back to our list of qualities of human intelligence. We now need to find out if crows can think abstractly. If you had asked Descartes or John Locke, they would have said, "You're bonkers." According to them, abstract thinking is uniquely human. One study looked at whether crows can do something like analogical reasoning, which means understanding not just the thing they see, but also the relationships between them. In the experiment, 2 crows were first trained to match objects by simple features like color and shape. Then they were tested on relational matching, choosing pairs that had the same kind of relationship as a sample pair, even though none of the items looked exactly the same. The crows succeeded at this task, showing they could go beyond surface features and respond to abstract similarities in relationships, something researchers had mostly seen in primates before. Pretty smart. Okay, but what about comprehending complex ideas? Crows, for example, are masters of object permanence, which is the understanding that objects still exist even when they aren't visible. It takes human infants at least half a year to start developing this understanding. That's why peekaboo is so delightful for babies. When you put your hands in front of your face, they genuinely believe you've disappeared. What a surprise when you magically rematerialize in front of their very eyes. In other comprehension of complex ideas, one study set out to discover if crows could be trained to translate perceived numerosity into number of actions. As expected, the crows had absolutely no issue blasting through this task. Since we're already talking about crows outperforming human children, it's worth mentioning that crows are capable of recursion, the ability to identify one idea within another. Like, the man the lady talked to ran. The crows performed at the same level as 3 to 4-year-old kids. We actually got a chance to speak with one of the researchers who did this study to tell us about her work and her experience with some of the smartest animals on Earth.
My name is Danielle. I'm a postdoctoral researcher studying crow cognition and communication at the University of Tübingen.
Since we can't just ask crows to tell us how smart they are, one of the key things researchers have to do is design ways to test their abilities.
It's very difficult kind of in designing these studies, right? Because we can't ask them exactly what are you thinking or what can you do? And so we kind of think about, oh, what are the things we want to test potentially? And how do we design a project that gets at this? So one of my studies was teaching crows how to kind of count out loud, like could they control the number of vocalizations that they made? And initially, they just had to learn like how to associate like a cue with making that number of vocalizations. And it's not like I could tell them, oh, I want you to do this. They had to figure it out themselves. And one of the mistakes I made early on was the fact that, oh, they were really good at this task because they just saw a cue, made the number of vocalizations. And then I realized they were actually kind of cheating a little bit. They were just vocalizing until they got a reward. And so then we had to redesign the experiment so that they had to peck at the screen to report that they were done vocalizing. And this allowed us to be like, oh yeah, they can control the number of vocalizations and then report, this is what I've done before. So really kind of careful experimental design is what I would say is really helpful.
Yep, the crows were outsmarting literal scientists by finding ways of getting treats as easily as possible. They are smart. We'll get back to Dr. Liao in a bit. Okay, moving on to our last test for human intelligence. Can crows learn from experience? If you've ever pissed off a crow, you'll know this to be true. Crows will hold decades-long grudges if you mess with them. American crows are known to recognize human faces, especially those faces that have crossed them in the past. If that wasn't bad enough, in the same way that crow parents pass down skills like tool use to their fledglings, they'll also pass down their beefs. Tick off a crow and they'll tell all their family and friends, who will join in the scolding of the perp if they dare show their face again. So they're smart, petty, and gossipy. That's a dangerous combination. But it's not all eternal grudges for crows. We know from observing them that making and using tools actually puts them in a good mood. One study showed that crows are actually intrinsically motivated to use tools. This means doing something just because it's enjoyable or satisfying. So using tools might not just be about food they get, they might actually be having a really good time.
And the New Caledonian crows, we think that they're special because they live on an isolated island with no woodpeckers, which is why they might have developed this tool use for foraging. Exactly, so there would be competition for that food source. Yeah, so as far as I know, this is not my area of research, but I think it's really interesting. It would be the New Caledonian crow and also the alala, which would be the Hawaiian crow, that seem to be using tools. And those are all islands with no woodpeckers.
If you've ever seen a woodpecker fighting a crow, now you know why. So what's next in crow intelligence research?
So this is one of the things I'm interested in is like how good are they at learning? And I think one of the reasons we see corvids like all around the world, I think they're not on like every continent except for Antarctica, is that they're like ridiculously adaptable and good at learning new things. So I think this is partially where like in the lab, we train them to do different tasks to kind of expose like what cognitive abilities they have.
Thank you, Dr. Liao. If you want to keep up with her work, click on the link in the description. Reasoning, planning, problem solving, abstract thinking, comprehending complex ideas, learning quickly and from experience. It seems that by every metric, crows fit the bill for human levels of intelligence. Now, who do we call to have the term bird brain stricken from our vocabulary?
Underneath these vast grasslands of North America lives the single most important species of its ecosystem. They rule the prairie from the underground, building burrows for other species, fertilizing the land, and barking incessantly at documentary filmmakers. This is the prairie dog.
Right now, I'm standing in the middle of a gigantic prairie dog colony in Grasslands National Park, Saskatchewan. This park is home to a species called the black-tailed prairie dog, which can be found from the prairies of Canada down to the Chihuahua Desert of northern Mexico. You gotta be careful when you're checking out a prairie dog's hole. That sounds gross. Wow.
Despite their name, prairie dogs are not, in fact, dogs, which becomes immediately clear as soon as you see one.
They are, in fact, members of the Sciuridae family and are closely related to the chunky marmots, the adorable chipmunks, and the tree rats that destroy my bird feeder every year. But unlike your adorable and slightly terrifying neighborhood squirrels, these cuties live in the ground. It can get pretty hot where they live, so they've evolved a pretty neat trick: become a pancake. This behavior is known as splooting. They'll find a cold patch of ground and spread out their body to radiate their heat into it. It's this summer's coolest trend.
There's one right in front of me. A prairie dog. Okay, he just squeaked and sounded the alarm to let his other prairie dog friends know that somebody's here who shouldn't be. Hi. Of course, I mean no harm. All around me, I can hear the calls of the prairie dogs as I walk through their colony, which is actually called a dog town, or as I like to call it, Squeakopolis.
These calls are part of a highly complex and nuanced language. Prairie dog vocabulary is more advanced than any other animal language that scientists have been able to decode.
But right now, I think they're just telling me to scram. They are literally on every single side of me. And it's interesting because as soon as one raises the alarm, that alarm spreads from one den to the next. You see one pop up from the hole, start screaming, and then other ones start popping up and screaming in tandem with them. And that kind of like travels down like a shockwave of sorts. It's very interesting.
Alert calls are a big part of their vocabulary. And while to an untrained ear it all sounds like a dog's chew toy, they can actually get very descriptive.
Oh my gosh, this colony is just making a racket. They're communicating among each other to let each other know what they're seeing. And all of those squeaks and chirps have very specific meanings. There are a lot of sounds, that's for sure.
The massive colonies are made up of family units called coteries. The families usually consist of one breeding male, several females, as well as their pups.
These sister wives will stick together their entire lives, while the males will move on and try to find other females to mate with every year. Typical.
The families even have their own language, allowing them to tell kin from stranger.
They don't just have cute sounds, they have a multitude of cute sounds. And they all mean something very specific. They've developed pretty much their own language.
Despite their massive numbers, they only mate once a year in early winter, and females only enter estrus for a single hour.
1 hour. Once a year.
She'll have a litter of 3 to 8 pups, and only half of them will survive their first year.
These little families are super tight-knit, though they're not always very good neighbors. The males are super protective about their harem, and won't hesitate to try and bite any trespassers.
There is also a theory that family units will call out to alert a predator to start a jump yip, what dogs would call a howl, and then quickly they'll shut up. So when the predator is closer, it's the other families that are making lots of noise and calling attention to themselves.
Wherever you find large colonies of animals, you're also bound to find large amounts of their bones. So I just found a little lower jaw. See how deep it is back here? There's a lot of room for muscle attachment. And the more muscle you've got to work that jaw, the stronger your bite force is. I didn't just find a jaw, I also found a skull. Look at this beauty. You see these sharp incisors at the front? Yeah, you don't want to get bit by that. It could do a lot of damage. These incisors will keep on growing their entire lives because they need to keep using them every single day for every little thing. They don't just use them for eating, they also use it for maintenance. They keep their area as tidy as possible so they always have a clear vantage point.
If you hadn't already guessed given the setting, black-tailed prairie dogs primarily eat grass. But they are opportunistic and will eat forbs, roots, sagebrush, and cacti, even insects given the chance.
So this prairie dog spotted me, sounded an alarm, and then scampered off from that hole to the next one, hoping to lose me.
The holes that they pop out of are part of a vast underground network of tunnels. The biggest dog town ever discovered was 64,000 square kilometers, which is just a bit larger than Manhattan.
Oh my gosh, this prairie dog really knows how to pick a home. Right at the exit to his burrow, he's got this incredible view. Look at all that. Oh, I'm just gonna have a romantic sunset with my new friend, the prairie dog.
These mega dog towns can be home to as many as 400 million prairie dogs at a time. But since their tunnel networks are so massive, a lot of other species use them for shelter.
You definitely need to be cautious while approaching a prairie dog's den, because you never know what kind of animal might actually spring out of it. As a keystone species of the prairies, the burrows they dig serve as homes for all kinds of prairie dwellers, such as shorthorn lizards, burrowing owls, and swift foxes.
These are just a few of the dangers that prairie dogs have to deal with. With such massive colonies, prairie dogs are the #1 source of food for many grassland predators. In fact, prairie dogs support at least 136 other species in the grasslands, which is nice for the 136 other species, but kinda sucks for the prairie dogs. Thanks for taking one for the team, little buddies. Their two advantages are that they can call out to alert their compatriots of danger, and they can escape through their massive, winding network of tunnels.
It's sunset, and things are getting wild in the dog town. Right now, we're experiencing some of the incredible pressures that prairie dogs experience. There is a coyote out there scanning for its next meal, as well as a burrowing owl. Whew, don't envy these guys right now.
Coyotes have been observed teaming up with badgers in order to hunt prairie dogs. Coyotes are built for speed, but they're too big to pursue their prey into tunnels. Badgers, on the other hand, are clunky runners, but built for digging. And so they have formed a mutualistic relationship. The coyote will chase the prairie dogs on land, and when they run into a tunnel, the badger will be waiting inside, having gone in from the other side. Or, if the prairie dog is already underground, the badger will charge in to flush it out, where the coyote will be waiting.
These prairie dogs are pretty much the cornerstone of the ecosystem here in Grasslands National Park. They play a role for just about every species out here.
Because they are such an important prey species, when their numbers take a hit, it releases a wave through their habitat that has a profoundly negative impact on the species that rely on them to survive.
Prairie dog numbers have gone down by 95% since Europeans arrived in North America.
Part of this is due to the bubonic plague, brought to North America by rats on ships, which decimated prairie dog populations in the 1800s. Yet the plague still persists today, and when it hits a colony, it will wipe it off the map. The other big impact we've had on them is destroying their habitat to create farmland. Cattle outgraze prairie dogs, and quickly will eat all the food that would otherwise be consumed by the prairie dogs.
As grazing competition for cattle and being potentially destructive for crops, many farmers have seen these prairie dogs as pests and have thus eradicated them from many of their natural ranges.
As a result of all of this, the black-footed ferret, which is a species of ferret that has evolved to primarily eat prairie dogs, is endangered. They've tragically been extirpated from the park. Sadly, there's just not enough prairie dogs to go around anymore.
Here in Grasslands National Park, despite the hundreds of prairie dogs that you see around me, there are still not enough to reintroduce the black-footed ferret into the park.
But there are several ongoing conservation programs, and hopefully soon we will see a resurgence of the prairie dogs and the many endangered animals that rely on them.
Oh, I heard the squeak, and I see him now.
There's a prairie dog straight ahead of me. I'll approach cautiously, see how close we can get. Oh, they're so small and so sweet. They're like fuzzy baked potatoes. Oh, he sees me now. Curious though. This one's small and doesn't seem to have the black tip of the tail. I dare say it's actually a ground squirrel.
Black-tailed prairie dogs share the park with the more northerly Richardson's ground squirrel, commonly called the prairie gopher. They can be tough to tell apart from a distance, as they are quite similar looking. But the ground squirrels are about half the size of the prairie dogs, and they lack their characteristic black-tipped tail. The females live in social groups made up of only their female kin. The males, on the other hand, do not socialize with anyone. As a result, they get into some pretty epic confrontations.
Oh my gosh, I can see two tussling over here. I'm gonna try and catch up to them. Ah! Andres, can you see these guys tussling? Oh yeah, they're playing a game of tag or something. It's really bittersweet leaving this place. I'm very happy to see it thriving, but I am sad to leave it. Bye, grasslands. Hope to see you again soon.
Behold! The greatest impersonator of the animal kingdom. This small cephalopod can be found in the shallow waters of the Indo-Pacific. Or maybe more accurately, it can't be found in the shallow waters of the Indo-Pacific. That's because it's often pretending to be something else entirely. This is the master of disguise, the Mimic Octopus. The Mimic Octopus is an underwater changeling with the power to seemingly transform into other species at a moment's notice. At just 60 centimeters maximum, the Mimic Octopus, officially known as Thaumoctopus mimicus, is quite demure compared to its largest cousin, the giant Pacific octopus, which can reach up to 4 meters across. Most octopus species share the ability to change their color, shape, and texture in the blink of an eye. In the case of the Mimic Octopus, they take it a little further, doing a complete quick change faster than you can say, "I'll have the octopus ceviche." Camouflage in nature is used to help prey avoid being eaten. In some cases, camouflage is also used by predators to get close to prey without being detected. This adaptation is a serious evolutionary flex. Camouflage tactics usually involve blending in seamlessly with the background. But for a creature as talented as a Mimic Octopus, the point of changing its appearance isn't to blend in. It's to stand out and scream, "Come at me, I dare ya!" Researchers have reported seeing these octopuses transform into everything from mantis shrimp and giant crabs to seahorses and starfish. But their preferred disguise is that of creatures that are packed with dangerous venom. This intimidating facade ensures that any predators floating by are fooled into thinking this otherwise delicious octopus is something that's definitely not on the menu. Like many adaptations, the Mimic Octopus got so good at mimicking because of its chosen habitat, in the open sandy shallows near river mouths. These areas are teeming with predators like large bony fishes, sea snakes, and sharks. To stay hidden, most of the time they'll either be peeking out of their burrows or camouflaging motionlessly with their surroundings. But as soon as they have to move, their cover is blown. That's when it becomes very important to pretend you're someone else. The octopus, for example, puts on a venomous disguise, dressing itself up as a lionfish. After matching the lionfish's distinct stripes, the octopus mimics its venomous spines by holding its flattened tentacles up around its body. Not many creatures have the blind courage to swallow a spiny and venomous lionfish, so this disguise works quite nicely as a warning to would-be predators. Here, the octopus raises its crimped tentacles to mimic a sand anemone, which packs a toxic sting. In order to sell the deception, the mimic octopus does more than just transform its appearance. It even adopts its target species' movements and behaviors. Hey, it might not fool you, but it certainly fools its predators. When it transforms into a venomous jellyfish, for example, the mimic will wave its tentacles the same way a jelly does, as it propels itself upwards through the water. Here, we see a mimic octopus transforming into a banded soul before our very eyes. By holding its arms flush against its flattened body, the octopus can easily pass for this poisonous fish. When in soul mode, the octopus glides across the bottom just like the fish to fully sell its clever disguise. Here, an octodaddy takes the shape of one of the world's most venomous snakes, the banded sea crate, to ward off potential predators. It achieves this threatening look by pulling 6 of its tentacles out of sight and stretching out the remaining 2 in opposite directions. It then, of course, dons the striking black and light gray stripes that are the hallmark of this highly venomous snake. Here is a mimic octo pretending to be a moray eel, a fish that packs a powerful bite and whose colors resemble those of venomous snakes. So this octo may actually be mimicking a non-venomous eel who itself is mimicking a venomous snake. Things can get very meta on the seafloor. If mimic octopuses weren't shape-shifting enough, they are often mistaken for their closely related but smaller cousin, Wonderpus photogenicus, otherwise known as the Wonderpus octopus. Admittedly, they do look quite similar, but there are a few small differences, most notably the long eye stalks of the Wonderpus, which give it an adorably cartoonish look. Both the Wonderpus and the Mimic have Oscar-worthy acting abilities, but even though the Wonderpus has more charisma, the Mimic seems to have more range, at least for what researchers have observed in the wild. Octopuses can color change thanks to specialized cells called chromatophores, located just below the surface of their skin. The center of each chromatophore cell contains a sac of pigment in colors like black, brown, orange, or yellow. To change color, each sac stretches or shrinks to give the right hue. Not only can octopuses change color, they can also change texture. Projections on the skin, called papillae, adjust to create textures ranging from smooth to bumpy. A true testament to their ability to hide in plain sight is the fact that mimic octopuses weren't even discovered until 1998. Our very limited experience with these incredible mimics means that we're just at the beginning of our understanding of what they can do. Right now, we don't even know for certain the extent of the mimicking capabilities of these octopuses. Scientists believe that we've only seen a fraction of the disguises these mimics can do. Who knows? Maybe your favorite YouTube show is run by mimic octopuses pretending to be nature documentary filmmakers. So what should we talk about next? Please let me know in the comments, and don't forget to subscribe for new episodes every week. Thank you so much for watching, and see ya! Ever had a bad night's sleep? Imagine trying to catch some Z's while floating in the middle of the ocean. Or even worse, sinking to the bottom of the sea. Ugh, what a nightmare. But it does make you wonder, how do animals sleep underwater? Some oxygen breathers spookily float close to the surface. Some others only sleep half a brain at a time. And some genius invertebrates have nightmares that you can see in their skin. Let's get into the amazing adaptations of the animals who sleep underwater. Hi, I'm Danielle Dufault, and you're watching Animalogic. Today, we're investigating how marine animals sleep. How do they rest in an environment that requires constant movement? But before we get into the specifics, let's take a step back to understand the basics of sleep in the first place. Even though sleep may feel like a simple process, there's a lot more to it than shutting your eyes and drifting off into the darkness.
There are several stages of sleep that make up a sleep cycle someone goes through during the night. Your brain behaves differently during each of these stages. Scientists study them by attaching electrodes to the head and watching brain activity while a person sleeps. This is called an electroencephalogram, or EEG. We'll get back to EEGs in a bit.
Without getting too far into the weeds of neuroscience, there are two kinds of sleep: REM and non-REM sleep. When you start drifting off, you begin in non-REM sleep, moving into deeper and deeper stages of rest.
After your brain has had enough time, it shifts into REM sleep, the phase with rapid eye movement. This is when we dream. Our muscles usually freeze during this part of rest, which prevents us from acting out our dreams. Throughout the night, your brain will cycle through several REM and non-REM stages. Both are essential for the brain and body, and without them, humans and many other animals would die.
Many aspects of sleep still remain a mystery to scientists. But one thing is for certain: sleep is critical for life. Knowing this, it becomes even more important to ask: how the heck do marine animals sleep at all?
Let's start with one of our closest aquatic relatives, cetaceans like whales and dolphins. These animals have a unique sleeping adaptation. They put half of their brain to sleep, while the other half is still awake.
Cetaceans have little to no REM sleep, which is weird because without it, we have issues with memory, mood, learning, and even increased risk for certain diseases, like dementia. Some scientists think that sleeping with one side of the brain at a time may help compensate for this lack of REM. Cetacean sleep may also simply be more efficient, doing the work of REM without having to be in it. I envy that.
Dolphins will spend about 8 hours per day in this partially awake, partially asleep state, spending half the time resting each hemisphere in 2-hour-long sleep shifts. Talk about multitasking. But why?
Obviously, being an air breather but sleeping underwater isn't the best combination. And so these animals have had to figure out how to not inhale water and how to surface when needed while sleeping. Hanging out right at the surface of the water can make you a prime target for large ocean predators, so they have to stay a little deeper where it's darker and safer. So this kind of sleep gives them the opportunity to get some rest, while also being able to balance these other very important factors.
You might be wondering what these animals look like while in this state. Marine mammals don't actually need to be totally still while sleeping. They usually just swim slowly or use basic movements of their flippers and fins to keep themselves warm and their bodies stabilized. They also sleep with one eye open to remain vigilant while also giving half of their brain a break. I should try that sometime.
While the thought of a human sleeping with one eye open sounds like something out of a horror movie, for these creatures, it's nothing but a day's work, or rest, in the marine animal kingdom. Even though most research on marine mammals has been focused on dolphins, researchers have also discovered unique patterns of sleep behavior across other cetacean species. For example, sperm whales